Hi guys, Mrs. Irwin taking over Chapter 5 after Miss Butcher did a fabulous job on Chapter 4. We're going to start with 5.1, which is polynomials and polynomial functions. So remember from your English classes that poly means many and nomial means term. So we are going to be looking at polynomials, what we can do with them to manipulate them, but also polynomial functions, so graphing them. Start off with this little joke to the left. After last unit, you should understand this joke, but hopefully that doesn't mean you don't have any friends. So what is an exponent? An exponent is a number that says how many times to multiply the base. So 5 cubed, 5 would be the base. Obviously 3 is my exponent. 5 cubes means multiply 5 times 5 times 5, and that would give me 125. X to the 5th means multiply x 5 times. If I had 2 times 3 squared, I do not multiply 2 times 3 to get 6 and then square it. The first thing I do is, if you want to write it out, it's 2 times 3 times 3. Remember, in PEMDAS I'm doing exponents. So now I can multiply left to right, so that's 6 times 3, which would be 18. So now let's talk about properties of exponents. Properties of exponents. The first one is product of powers. So if I have two of the same bases with exponents being multiplied together, I get x cubed times x squared, and we know that x times x times x times x times x, that's 5, would be x to the 5th. So the rule here is add your exponents. You get x to the 5th. Power of a power, so now we're taking a power or an exponent, same thing, and putting it to another exponent. So that means I start with these guys out here. I want 3 x squareds, which turns into x squared, x squared, x squared, which is x to the 6th. Notice this rule is x to the 2 times 3, and then I get x to the 6th. Power of a product. So let's assume we're taking this product, which is 2 times x squared times y squared, and putting it to a power. The first thing you need to remember is everything has an exponent on it. If it isn't seen, it's 1. So in a product of a power, I actually want 2xy squared times 2xy squared. This would give me 2xyy times 2xyy. And remember, this is multiplied, so this is 2 times x times y times 2 times x times y times y. So I'm going to multiply the 2's. These are two of the same bases, so I add those exponents. And these, again, all have an exponent of 1, so I get y to the 4th. Okay? School bells. Problem with creating videos while you're at school. So let's do this easier, because that would be a long time to figure out this problem. I'm going to quote-unquote distribute this exponent to the other exponents. So I get 2, 1 times 2 is 2, x, 1 times 2 is 2, y, 2 times 2 is 4. And the only thing I now have to adjust is the 2 squared, so 2 squared is 4, x squared, y 4th. Same answer, but a little easier math. So let's talk about negative exponents. A lot of this is review. You did it in Algebra 1. I know in geometry you have to use exponents when you're multiplying out lengths and sides that are in exponent format. So a negative exponent is not allowable in math, just like an I in the denominator, a square root in the denominator. So if I have a negative exponent in the numerator, now remember, if I don't have a denominator, it's over 1. So if I have this in the numerator, I take the x to the negative fifth, I put it in the denominator and make a positive. The same thing is with a negative exponent in the numerator, I make it denominator, I make a positive and put it in the numerator. Okay? 0 exponents. Anything to the 0 is 1. Anything to the 0 is 1. Even this huge, long that would equal 1 because everything inside this parenthesis is 1. If I had 2x squared y 0z, only the 0 is attached to the y. So the y would become 1, and if I'm multiplying, that really means I'm multiplying by 1. So this becomes 2x squared z. Quotient of powers, if I have x to the fifth over x cubed, that means I have x times x times x times x times x in the numerator, and x times x times x in the denominator. Those would cancel, leaving me x squared. You can see that this would be x to the 5 bottom minus top equals x squared. If I had x cubed over x to the fifth, and I did that, I would get x to the negative 2 bottom top minus bottom stays on top. But we know we're not allowed to have a negative in the numerator, so I'm going to move that to the denominator. Okay, power of a quotient. Okay, last one. This is a quotient, which is division. Okay, let's make sure we understand that's division. This is a quotient to a power. So remember, again, everything in here has an exponent. So I'm going to distribute to the numerator and to the denominator. So I get x to the negative 2 over y to the negative 4. Negative exponent in the numerator would go to the denominator. Negative exponent in the denominator would go to the numerator. So I get x squared on the denominator and y to the 4th in the numerator. So Miss Butcher told me I only have 15 minutes, so I'm at about halfway, so we're going to do this a little quicker. So don't forget everything in here has an exponent. So that negative 4 has an exponent, and that 2 is going to distribute to both of those. So since the negative 4 is in parentheses, it's negative 4 squared times 2 to the 5 times 2 is 10. Negative 4 squared is 16. 2 to the 10th is 1024. And if I multiply those together, I get 16,384. Okay, again here, this negative exponent goes to the numerator and the denominator. So I'm going to get 11 to the negative 5th over 11 to the negative 8th. Negative exponents switch where they are, so the 11 to the negative 5th comes to the denominator, becomes positive. The 11 to the negative 8 goes to the numerator and becomes positive. Do a little review of scientific notation. Remember, everything has a decimal. In scientific notation, I'm going to bring that decimal back so that there's only one place in front of the decimal. So I'm going to go back 1, 2, 3, 4, 5, 6 places. So this number turns into 6.54321 times 10 to the positive 6th, meaning I want this number to get bigger. Again, I already have a decimal here. I want to move that decimal so there's only one number in front of the decimal. So I'm going to move that decimal right here by the 1. So I'm going to move that 1, 2, 3 times to the right. My number then, scientific, would be 1.234. I moved it 3 times to the right, but I want to get smaller, so I'm going to put a -3. Writing in standard form, the positive right here means I want my number to get bigger, so I'm going to take 9.87, move it 3 times to the right, and I get 9870. There's my decimal. And in this, decimal is negative, so I want to move that decimal back 2, and I get 0.0654. Okay, multiplying scientific notation. The first thing we do is multiply the numbers, and you get 98.022. And then since these bases are the same and I'm multiplying, remember I add my exponent, so I get times 10 to the 10th. But I have a problem here. I'm only allowed to have two numbers in front, one number in front of the decimal, and I have 2. So I'm going to move that back one more time. And my answer is going to be 9.8022 times 10. Now, I had 10. I want to make it one more bigger, so I go to the 11th. Okay? In number 2, I just add my exponents. That's 5 plus 6 is 11. Subtract 8 is w cubed. This -2 is going to distribute to both of these. So I get c to the -2 over d to the 8. Okay, I'm not allowed to have negatives. This one's negative. This 8 is positive. So that 8's positive. He's not going anywhere. The only one that moves is the negative. So the c to the -2 moves to the bottom, but it becomes positive. And d to the 8th stays in the denominator. Since I have nothing left in the numerator, I put a 1. Okay, here I have an a cubed to the -3. So now that -3 goes to the bottom and becomes positive. A to the 5th is positive, b squared is positive, so I don't move them. But now I have two bases that are alike, so I add my exponents and get b squared over a8. All right, last one. Don't forget, this 2 has an exponent. I'm going to distribute that 3 into everything, and I get a 2 times 3, b -1 times 3, 2 1 times 3, a 3 times 3, b 3 times 2. I have a, so we're going to move the b to the 3rd in the denominator. I have a's in the numerator and denominator. Remember, the rule is subtraction, so it's a to the top minus bottom, 6 minus 9, stay on top. 2 cubed is 8. The b to the -3 is going to go to the denominator. The b to the 6th is positive, so it stays in the denominator. I'm going to move that a cubed to the denominator, which would leave me 1 in top. The 8, I'm going to put the a cubed. We always write them alphabetically. And then since these bases are the same, I'm going to add those exponents and get b9.